Okay. So this is going to be the, okay, I got to change slide. Or not. There we go. This is going to be the second method of graphing accurately. And so the main difference between the two methods is how the equation is written. So if your equation has a middle term, like the B number, then you're going to graph it like we did yesterday. If your equation doesn't have a middle term, so no B, then you're going to graph with transformations. Well, you could still use yesterday's method with these equations too, but transformations are going to be a lot quicker. So this one is preferred if you're able to, but you have to use the other method if it has a middle term. I'll put it that way. Yeah, you're right. In the homework, it could have been these as well. Well, I guess I don't have many of them, but there's not many of you here. If you guys wanted, I do have little half sheets of graph paper. If you wanted to use that today, you don't need to, but just know that it's here if you want some. Okay, so what I'm going to do first is I'm going to graph the parent function, which is just regular x squared. And the way that we're going to graph that is it starts at 0, 0. And then over 1, up 1. So like if I put 1 in place of x, the answer is 1. So I go over 1, up 1. And then if there's a 2 in place of x, 2 squared is 4. So it'd be at 2, 4. And then we talked yesterday a lot about like the twin pairs or this, whatever you want to call them, the mirror images. That exact same thing would be here. So this is called the parent function because it's what all of the parabolas are going to be. It's so hard to draw. It's nice. This is what all the parabolas are going to be based off of. Now, if you have a number in the front of it, that's going to affect its height, which makes it look skinnier, or I'll say wider. We'll be polite. So it makes it look skinnier or wider depending on the number. The transformation 3x squared, I would say, oh, that's what happened to the marker. I would say g of x is 3 times taller. Because there's a 3 in front of the x squared. So if I'm drawing these, remember how I went up 1 to get to that first point? Now I'm going to go up 3 times of that. So 1 times 3 would be 3. Instead of going up 4, I'm going to multiply that by 3 and I'd go up 12. So 3 times taller, when you graph it, looks skinnier, even though it's, oh my God, it's so terrible. It's taller, but when you graph it, it looks skinnier. That's a lot harder than it should be. So if you guys on the test or quiz or anything like that, if this asks for a description, I'm okay if you guys write it's skinnier, okay? Like I don't need a perfect description from you. So if you see 3x squared and it asks you, how is that different than x squared? If you say it's skinnier, am I right with that? Thinner, however you want to describe it. The real definition is taller, but I know most people don't use that wording. So then we're going to look at a half. Oh, there it is. Then we'll look at 1/2 x squared. We would say it's half as tall. And what's going to happen is it's going to look wider. So instead of going up 1 on my black one, the original one, I'm going to go up 1/2. Instead of going up 4, I'm going to go up 2. So the green one looks wider than the black one. Even though it's half as tall, it just looks wider. Uh-oh, Sophia, you're at home now too. Crap, pretty soon this whole class is gonna be home. I come back to school and you guys leave to go home. Let's go Soren. Soren, what would you say for the negative 2x squared, the blue one? What do you anticipate it's going to look like?
I'm not sure.
Okay, how about if it was just a 2 and the negative symbol wasn't there? What would the 2 do? Is it going to be skinnier or wider?
Skinnier?
Perfect. So the 2 would mean it's going to be twice as tall, so it's going to look skinnier. The negative symbol in front of it would make it upside down. So the blue one actually has 2 changes. And if you just want to write skinnier, that's okay. So when you guys get to Algebra 2, by then you'll kind of be expected to describe things more accurately. But this is the first time you're really seeing it and doing it. So negative 2, instead of going upwards, I'm going downwards. Okay. So my black point, I went up 1. So now I'm going to go down 2. The black point, I went up 4. So the blue one, I'm going to go down 8. My graph isn't big enough. Somewhere like right there. And then I'll draw their twin pairs. How are we doing on these transformations? Are we okay with this? So there's only 2 different kind of transformations we're going to work with. The one is talking about the height of it. So like if it looks skinnier or wider, and then we'll do the other transformation next. So we'll focus on this one first. How are we feeling about this one? Are we okay with how to tell if it's up or down? She'll go with Adeline. How do we tell if it's going to be up or down? Like what do the ones that are going to be downwards have on them? Perfect. If there's a negative sign in front of it, that makes it upside down. The number tells you how tall it'll be. Okay, second transformation is going to be moving it up or down. So I'll draw the original one again. You guys might be able, you should probably draw a new graph. I suppose it would get super crowded otherwise. So I'll draw the original one again. I went over 1, up 1. Actually, I can do that in gray, I bet. So those lines I drew are how you decide how to draw original x squared. I always start with a point at 0, 0, and then I'd go over 1, up 1, over 2, up 4. Because I get those numbers from squaring them. So this is what I base all of my changes from. That's why they call it the parent function. Now, when we did things taller or shorter, it changed the height of the point. Now that we're going to move one up and down, it still kind of changes the height of the point, but it doesn't change how far away you move. So a +3 at the end would mean g of x is up 3 from f of x. I should put that, but I just didn't have room. Usually. So I'm going to take all of these points that I drew for the black one, and I'm going to move them up 3. So instead of being at 0, 0, I'm now at 0, 3. And then from here, I'm going to go over 1, up 1, over 2, up 4. And that's how I know where to put the points, because I know the shape of the original one in black. Do you guys think you could draw the green one on your own? Try to draw the green one on your own, x squared minus 2. And part of the reason I have these separated by description and the picture is because when we get to the test, there'll be questions just asking you what the changes were. Like you don't have to draw them. It'll just be asking you what the transformation is. And so you would just write it in words like this. Oop. Okay, if you drew them correct, the starting point, the vertex, would be 2 down. And then I would go over 1, up 1, over 2, up 4. So then I keep that same shape. Now I'm keeping the original shape because, oh, that was really big. I'm keeping the original shape because there's no number on the x squared. The number on the x squared is what changes the shape. The number out front, like at the end, tells you where you start from.
So how do you know where to put your, so you have like the one at the, like the dot spot, the 3, and then you have it at 1 and -1, and then the 2 above that. How do you know like where you are to just decide?
Are you asking how I knew where to put this point
No, like
up there?
no, like above the yellow where you put. So like at 2 and -2 that are red. Oh, you found from or
Are you talking about this one?
down.
So the top points.
Yeah.
Okay. So on the original one, when I went to over 1 and I squared that, 1 squared is 1. And if I square 2, so like over 2, if I square 2, I get 4.
Oh, okay.
So that's how we know how far up to go. And then the next page is going to be combining them. So it's still just the 2 changes, but we'll kind of go over how to figure it out. And this is the only lesson today. It's really slow to do them, but this is the only lesson today. Once you get the hang of it, they go real fast. I'll give you a minute to write this down first. I suppose I've been kind of flying through. I heard I got an email anyway, so I better read it. No. Let's pick somebody. Oh, no, Ayla got off. How about Callie? Callie, do you think you could help me on the red one? It has two changes. What are those two changes? Or Jamad? Jamad, are you there? Caleb?
Yeah.
Okay. Well, we're 1 for 3. What are the two changes on the red one?
Mm,
The order you say them doesn't matter. But there's two
down-
different numbers. We've got a 2 and we've got a -1.
It's down 1.
Down 1, good.
And
And the
skinny.
2, you can say it two different ways. So I cut you off.
Skinny and higher.
It's going to be taller, twice as tall.
Yeah, and skinnier.
2 times taller, or you can say it's skinnier. Okay, good. So the down 1 is what we'll start with to draw it. So I'm going to go down 1 because that's going to tell me where my starting vertex is from, like the starting point. Now, normally I would go over 1, up 1 and put my point. But I'm making it twice as tall. So instead of going up 1, I'm going to multiply that by 2 and go up 2. So like it originally was going to be there where that X is, but I had to go up twice as far. So up 4, the original one would be right there. But instead of going up 4, I have to double it and I have to go up 8. So my new point is right there. Do you guys want me to kind of draw? Like, does it help if I do this? I don't know if that makes it look more complicated or not. The original one would follow those gray lines where the red X's are. But since I've got a 2 in front of it, that makes everything twice as tall. So I basically went up an extra amount. That's why there's that extra space. So instead of going up 4, I went up another 4. Instead of going up 1, I went up another 1. Does it feel a lot harder when there's more than one change? Probably. Okay. Would it help if I drew them separately? Maybe we'll try that on the green one. We'll draw it in stages. So the green one has 3 changes. It's up 3. It's half as tall or wider, you know, however you want to describe it. And then the third change is upside down. So let's say I go up 3. That means I'm going to start from here. And a normal graph would go over 1, up 1. I'll just kind of put X's there for now. Over 2, up 4. And then I'm drawing the twin pairs over on the side. So where those green X's are, that would be regular x squared plus 3. But now I have a half. Let's pick a different green. I'll do darker green. A half x squared would mean I only go up half as much. So where those X's are would be my points. So that's going up half as much. And then my last change is to go down instead of up. So instead of going up 1 square, I would go down 1 square. Instead of going up that many squares, I would go down. My eyes are way too old to read that. So this would be the final one. Does it look worse when I draw those X's because there's lots of stuff up there now? Okay. I want to try to find the easiest way for you to follow it. It seemed like you guys were pretty good with the two things separate. But putting them together makes it feel a lot harder. Do you guys want me to redo any of this? Like, would that be easier? Did I break your brain? Kind of. I can't break your brain on Star Wars Day. I definitely killed you off. Do you want me to move on? Are you okay with this? Should I put up another one for you to graph on your own? Okay. Okay, we have one last topic that you'll probably be fine with. So at the very beginning, remember how we talked about twice as tall, half as tall, things like that? And I talked about skinny, wide. You're going to get questions where you'll be given a bunch of them and be asked to arrange them. Looks like this one says from narrowest to widest. So it's kind of just asking if you understand how the numbers compare. Now, I made like a little number line because I thought that might help you if I kind of labeled that. And I could be totally wrong. If it's regular x squared, that's like 1 x squared. So 1 is kind of what you compare everything to. So 1 is normal. Numbers bigger than 1, like I'll just say 10. The bigger the number, the skinnier it gets. The closer to 0, 0 being, well, you can't actually have 0. So as close, oh, whoa, what did I click? What the heck happened there? See if I got my pen back. Okay. Oh, but I lost the marker. As closest to 0 as you can get would be the widest you'd get. Now, you'll notice that this number line has nothing with negative numbers on it. And does anybody know why? Like, what did the negative, I'll just go back to Adeline. I think you answered this one earlier. What did the negative symbol mean again? It makes it go upside down. So a negative symbol means nothing according to how wide it is. So like we have two of them here that have negative symbols. These negative symbols mean nothing. We only care about the number in front of it, not if it's negative or not. Okay, so which one's the narrowest? Let's go with Alex. Which one's the narrowest out of those choices? A, perfect, 4x squared. So 4x squared, the 4 is the biggest number, so it'd be the skinniest. Do you want to just read off all of them off then probably? What would be the next one down? 2, correct? Then? Perfect, -1. So basically a 1. And then -1/3 would be the smallest number. The negative being meaningless. So this question is, once you understand it, is very easy. But if you're having trouble with it, like some people don't even understand what it says. If you have this little chart written down in your notes, that'll make the question on the test really easy for you. Okay, I am done with notes. You guys handled it pretty well. I did look at for tomorrow, because I believe tomorrow was the day you guys wanted the 2 lessons. And I shouldn't even say you guys, I think just one person requested it. But I didn't hear anybody saying they cared one way or another. So the lessons for tomorrow will fit perfectly fine to be able to do both. And then we'll do one lesson on Thursday, and then you have Friday to get work done.